Hello dear friends, welcome back. So before starting today's session, I would like to have the input as well as concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect somewhere and then we are going to go ahead. In yesterday's class, we had started a new topic within the control system, and the topic which we have started is been the bode plot. So basic criteria or the basic understanding of the bode plot is been already nurtured in the last class. Like the bode's plot would have the two different kinds of the plot. First talks about how the angle is going to get changed with respect to the varying frequency, which we call it BPP, bode phase plot, and similarly how the magnitude is going to change with respect to the varying operating frequency, and that we call it BMP. My dear friend, in compare with the Nyquist plot, we had a little bit difference. In Nyquist plot, the phase as well as the magnitude, how it was getting changed was getting addressed in the same figure, but here we are going to draw the two different figures. And at the same time, the magnitude which we have taken in case of Nyquist plot was in linear scale, but here we have taken the magnitude into the logarithmic scale. So what's the advantage we get? The most advantage what we get, it's been the compression. First of all, the complete mathematical expression which you have over the OLTF, now it could have been compressed with the larger value of omega. That's the first advantage we have received so far. The second advantage had been over the OLTF, the different kinds of the component you used to have in terms of multiplication as well as division. The multiplication gets converted in a form of addition, and similarly division gets converted in a form of subtraction. Not only that, we have also seen, if we'll talk about the curve, how it would look like, the magnitude curve, specifically BMP, that would be a straight line. And as it had been a straight line, analyzing as well as drawing the curve becomes much easy. Analyzing as well as drawing the curve becomes much easier. So till this point, I don't find any of the student would have any kind of doubt now. Any kind of doubt now. Tell me, till this point, each and everything is being clear to all of us? Yes, no? So let me focus over an important conclusion. We had drawn the BMP as well as BPP for first derivative term that had been S, second derivative term that's been the S square, first integral term that had been 1 upon S, and similarly second integral term that had been 1 upon S square. So now what we are going to do, we are going to take the generalized format. Like in future you may have S to the power of 3, S to the power of 4, S to the power of 5. You may have 1 divided by S square, S cube, S key, S to the power of 4. So we would try to learn how do we draw the BMP as well as BPP in that case. So let me do one thing. Let me take a reference now. Just a minute. I would request to each one of you, you should also draw this one on your copy because it's obviously very important one. It's very important. Just a minute. Yeah. Each one of us must mark it properly on your copy. So here we are going to draw the bode magnitude plot. Let's take this horizontal line which we had. No, it's been the 0 dB line. Similarly, this horizontal line had been plus 20 dB line, plus 40 dB line it had been, and similarly this has been plus 60 dB line. Similarly, when we go towards downside, it's been minus 20 dB line, minus 40 dB line, it had been minus 60 dB line, and last let's take it's been the minus 80 dB line. Let me take the reference of S square, S cube, 1 upon S square, 1 upon S cube. We are going to draw each of these 3 to 4 number of factors over the same plane, and that had been bode magnitude plot plane. This has been BMP plane. And let's take this vertical line, which what you had know, it's been omega is equals to of 0.1 radian per second, and here this vertical line which we had, it's been omega is equals to of 1 radian per second, and here it had been omega is equals to of 10 radian per second. Omega is equals to of 10 radian per second, and here you yourself would be able to see the omega had been jumped from 0.1 to 1, that means that had been the travel of 1 decay. And similarly, as the omega had been jumped from 1 to 10, again there had been the jumping of 1 decay. There had been the jumping of 1 decay. And I would request to each one of you, probably this could be the last class of the control system. I am not sure about it. What I would do, the topic which had been left out, it's been the state space analysis. It's already been dealt probably 6 months back. I would just share that link on our Telegram group. So the student is specifically the DS, you had been following my video since very beginning, so I would request to you, at least you can have the look of the complete video, probably 3 to 4 hours. I have just be dealing the concept of state space analysis, but I am not sure whether we are going to have the class tomorrow or not. Probably this could be the last class of the control system. This could be the last class of the control system, because I had been keep telling maintain at least 10 to 9 number of students over the video, but I have seen only 2 or 3 number of students are been watching concurrently since 4 to 5 days, which is not good. Already the control system is being covered, as I had committed that we are going to cover the complete control system. I am not going behind. So obviously what I would say, from tomorrow onwards, the 2 or 3 hours of lecture is being left out from the state space analysis. State space analysis, you can have a look of it. So the Telegram group, you have already, all of us, Telegram group, all of us had been added or not? Otherwise you should add there itself yourself, so that I would be posting the videos which are related to the state space analysis. You can take the reference of it. And that had been t.me abcd 1 2 3 df. Yes, no? And from my side, the control part would get over. Only and only one topic is being left out, and that had been state space analysis. And there, for the state space analysis, I would give you a link. You can just hop in there. And obviously you can take the reference of that. Now see what had been happening. If you take S, may I know for the S how much slope we had retrieved in the last class? Plus 20 dB per decay. That means as you move 1 decay forward, the magnitude has to raise by plus 20 dB per decay. So what I am saying, if you take a straight line, which crosses through like this, it's been plus 20 dB per decay. How did I know about it? Sir, this was omega is equals to 0.1 vertical line. This had been 1 and this has been 10. So obviously the jump was 1 decay. And similarly, if we'll talk about the jump in magnitude line, minus 20 to 0. So obviously there had been the shoot or the raise of plus 20 dB per decay. So one thing is been quite sure, if we'll talk about the slope of this curve, is being possessed, it is being plus 20 dB per decay. And this would stand for factor called S. Now in the same sequence, if we'll move forward, and if we'll see, or if we'll try to draw how the BMP would look like for the factor S square. S square used to have the slope is equals to of plus 40 dB per decay. That means in each decay, it has to increase its slope, or it has to increase its magnitude by 40 dB. So at omega is equals to 0.1 to 1 to 10, that had been the jump of 10 dB. So here what we can do, here, this is being the place of S square. Yes, no? Everybody would agree on it. And if we'll talk about the slope, its slope is simply gonna be plus of 40 dB. Yes. In the same sequence, if we'll move forward, what had been happening is, specifically if we'll talk about the term which had been present over your OLTF, is being S cube. Because of S cube, you are going to have the slope is equals to of plus 60 dB per decay. What does that mean by the plus 60 dB per decay? That means in each decay, you are going to have a raise of plus 60. So you had been you had been starting from minus 60 and within one decade you had reached to 0. So minus 60 plus of 60 becomes 0. So the raise had been plus 60 dB per decade. So what had been happening over there? What had been happening over there? This has been the another term, and how its BMP would look like, we can have a reference of it. This has been S cube. This has been S cube. May I know how much slope we had over here? The slope which we had over here, it's been plus 60 dB per decade. Plus 60 dB per decade. Till this point, I don't find any of the student would have any kind of doubt. Rather having s square, s cube, which had been the component because of the differentiation in time domain, if we had the integration over the time domain, like we had a factor called integration from 0 to t, would have the impact over the Laplace domain as 1 upon s, double integration 1 upon s square, triple integration 1 upon s cube. Because of that, now the slope would be negative in nature, which we have seen earlier. Because of 1 upon s, we are going to have the slope is equals to minus 20 dB per decade. That means as you move one decade, 0.1 to 1, that's been the one decay, 1 to 10, that's been the another decay. As you move one decay further, there would be the reduction in magnitude by how much? 20 dB. Then for the 1 upon s square, 40 dB. For 1 upon s cube, it's been the 60 dB. So one thing has been quite sure, if you wants to draw the BMP, just a minute, if you want to draw the BMP for 1 upon s or the first integral component, so obviously the slope is simply gonna be minus of 20 dB per decade. Minus of 20 dB per decade. Similarly, if you had the factor 1 upon s square, 1 upon s square, so now the slope would change to this. Yes, and here it goes. Last, never the least, is being this. This had come because of 1 upon s square. This has come because of 1 upon s cube. 1 upon s cube. So few of the important conclusion which we can retrieve out of this complete BMP which we have drawn for the derivative as well as integral term. As far as their intersection point is concerned, they had all been intersecting at the same point over omega is equals to 1, and that had been 0 dB. That had been 0 dB. I repeat, if you have a factor like 1 upon s, 1 upon s square, 1 upon s cube, 1 upon s to the power of 4, or in general 1 divided by of s to the power of n, where the n is supposed to be a natural number. Either you have a factors called s square, s to the power of 3, s to the power of 4, or in general s to the power of n, again where the n had been a natural number. Keep in mind they all are going to get intersected over the BMP at the same point at omega is equals to 1, and that had been 0 dB. That had been 0 dB. The next important point, may I know from which particular point the slope had been started? My dear friend, you cannot able to pinpointedly say that from where the slope is being started. If you'll go towards omega is equals to 0.01, still for factor s you will be getting the slope is equals to plus 20. If you will be starting from s is equals to 0.001, still you would be getting the slope is equals to plus 20 dB. In short, I can say whenever you had the factor 1 upon s to the power of n or s to the power of n, they are going to decide your initial slope. So may I know, because of these factors, whatever the slope you have got it over the BMP, would start from which operating frequency? You start from any of the least operating frequency, there also you would have the impact of this factor. And even if you go towards a higher operating frequency, like omega is equals to 10 to 100 to 1000, maybe 10,000, still the slope would be prevalent. So one of the important conclusion we can bring out of this is this factor has been a very, very crucial factor, and this factor had their impact since starting till last. So probably you guys must have a little bit idea about this factor. That's the first thing. And now in general I can say s to the power of m, where the m could be positive as well as negative real quantity both, or I may say the m has been a type of integer. Why I have taken m over here? Because it may be s to the power of plus 1 as well as s to the power of minus 1. It may also address the concept or case of differentiation as well as integration. So may I know s to the power of m indicates 20 mdB per decade. 20 mdB per decade. where if the m is being plus, you will see over the BMP, the plot is gonna be plus 20 dB per decay plot. Similarly, if m is being 2, the plot is gonna be plus 40 dB per decay plot. And similarly, if m is being minus 1, the plot is gonna be minus 20 dB per decay plot. And similarly, if n is being minus 2, it's gonna be minus 40 dB per decay plot. Did you understand? I would like to have the input from each one of you. Could you really understood the concept behind this graph which had been drawn in front of you? The conclusion is being 1 upon s minus 20, 1 upon s square minus 40, 1 upon s cube minus 60, s plus 20, s square plus 40, s cube plus 60. Intersection point would be at omega is equals to 1 over the 0 dB. In general, I can say 1 upon s is being minus 20, 1 upon s square is being minus 40. So in general, I can say s to the power of m would lead, the slope is equals to of 20 m dB per decay. If the m is being plus 1, it's being plus 20, m is being plus 2, it's a plus 40, m is being plus 3, it's plus 60, m is being minus 1, minus 20, m is equals to minus 2, minus 40, so on and so forth. So on and so forth. And one of the important most conclusion which we can retrieve out, it's been, it would affect your initial slope as well. You can't say from where the slope had been raised. If you start from omega is equals to 0.1, no. Even if you want, you can go behind also. If you want, you can go behind also. See what I'm saying? If you want, you can go behind also, like this also, like this also. So it would be like this. It would be like this. Yes. So I'm saying it would be affecting your initial slope. It would be affecting your initial slope. Let me go ahead. Now the next factor which comes in our mind, it's been, let's say you used to have this sort of factor, no? S plus 2, S plus 4, S plus 5, maybe at numerator, maybe at denominator, with the power of n, maybe with the power of minus n. So now the next factor do come in our mind, it's been 1 plus of S tau, and we would like to learn 1 plus S tau, how it affects the BMP as well as BPP. How it affects BMP as well as BPP. My dear friend, one thing has been quite sure, as the analysis is being done for the bodes, the domain of study is gonna be frequency domain. So what had been happening over here? Let's take it had been GSHS. This had been your GSHS. It's been 1 plus of S tau. The domain of study is going to get changed. Domain of study is going to get changed, and now the domain of study would shift from S to omega, frequency domain. And that had been 1 plus j omega into of tau. J omega into of tau. Till this point, I don't find any of the student would have any kind of doubt now. Now, what we had been doing, we had been focusing over the two different part of this complex function. First is going to be its magnitude part. As far as the BMP is being concerned, I would be talking the magnitude in dBs. And similarly, the second part is going to be the phase part. As far as the BPP is concerned, I would be talking about its linear phase. May you know how the magnitude would be calculated? My dear friend, the magnitude of a complex variable used to be root over of the square of its real part as well as the imaginary part. But as the values has to be calculated in dBs, we would also operate a logarithmic function with 20s. So it had been 1 plus of j omega tau. 1 plus of j omega tau. Similarly, phase, if we'll talk, this had been first quadrant. So the angle which would be offered by this function is simply going to be tan inverse the part of imaginary, that had been omega tau, divided by the part of real, and that had been 1. Yes, no? Let me do one thing. Let me take its magnitude. It's simply going to be 20 log base 10, and here it becomes root over of 1 plus of omega tau, which has been raised to the power of 2. What I am going to do, we are going to take approximation at this point, and this had been a very, very important approximation. If you are able to understand this approximation, probably you will not have any problem at least drawing the BMP. What we had been doing, at very beginning, I have taken this factor as being very smaller than the value of omega tau. So I have taken the value of 1 had been very smaller than the value of omega tau. Or I can say the omega tau is been very, very smaller than value of 1. Or I can simply say the omega had been, or the operating frequency at which the analysis is being made is being much, much smaller than the value of 1 upon tau. In that case, what happens? If the omega t is much, much smaller than 1, omega t square would be even smaller than 1. End of the day, it simply becomes 20 log base 10 of 1. And as we know, the log base 10 of 1, maybe log base a of 1 is being simply 0. So I can say when the operating frequency omega is much smaller than the 1 upon tau, the bode magnitude plot would be simply a 0 dB curve, or I would say it would have a slopeless curve which would be lying over the 0 dB. Now if I take another situation, omega t is much greater than 1. Omega t is much greater than 1. In that case, what happens? Now the 1 can be neglected in front of omega tau. And now the omega is square as well as square root is knocked off. The factor which we had, it's been 20 log base 10 of omega tau. Omega tau. Yes, no? So the factor which we had over the hand, it's been 20 log base 10 of omega tau. Omega tau. Now what we would do over here? Let me do one thing. Take the reference of 20 log base 10 of omega tau. Omega tau. Let me feed the operating frequency omega is equals to 1 upon tau first. May I know what's going to be the magnitude over here? Omega is equals to 1 upon tau. Tau knocks off 20 log base 10 of 1 simply means 0 dB. It simply means 0 dB. Similarly, let's take the omega is equals to 10 times of the older operating frequency. 1 decade forward we have went. In that case, what happens? Omega is being 10 times 10 divided by tau. Tau goes out. 20 log base 10 of 10, it's simply been plus 20 dB. So what had been happening in each 1 decade improvement, the slope had been changed or the magnitude had been changed by plus 20 dB. So what we can say from here also, the conclusion had been very same. Sir, we had the improvement of the magnitude by the plus 20 because of the factor 1 plus s tau. From where the slope had started, you yourself would be able to see the slope had started from this point onwards, because before then this, there was no effect because of this factor. There was no effect because of this factor. So what's the conclusion we can retrieve here? Forget about all the stuffs which we have studied so far. All of these stuffs which we have studied so far, I think now we had to focus over the few of the important aspects, and straight away I would take few of the numericals from there onwards. See, if you have a factor s to the power of m, no, because of that you are going to get the plus 20 dB, plus 20 into m dB per decay, m dB per decay. From where it would start? It would start from starting from which value of operating frequency it would last till the highest operating frequency. I would say the impact because of s to the power of m would last for all operating frequency of omega, that we have already seen. Similarly, the second important point which I would like to write over here is been now you had this sort of factor 1 plus of s tau. My dear friend, the concept remains very same. When we had one number of 0, the slope was plus 20. When we had the two number of zeros, the slope was plus 40. When we had one number of pole, minus 20. Two number of pole, minus 40. So what I am saying, the number of zeros as well as number of poles are going to decide the slope. As far as this factor is being concerned, its slope was started at very beginning or very least value of operating frequency, but here the slope had started only and only when the omega was quite greater than the value of 1 upon tau. So what I would say, if you had a factor of 1 plus s tau which had been raised to the power of m, because of that you are going to again have the slope is equals to a plus 20 m dB per decade. May I know from where the slope would start? The slope would start from omega greater than equals to of 1 upon tau, and if you will take the reference of omega lesser than equals to of 1 upon tau, the slope would simply be 0 dB per decay. 0 dB per decay. Yes, no? Okay, then let me take few number of numerical fatafat and we would try to learn how to draw the bode magnitude plot for those questions, and this sort of questions had been repeatedly been asked. Let me take the first question. Is being the OLTF is being supplied along with this problem is being 1 divided by of s plus 1. You have to draw the bode magnitude plot for this given OLTF. My dear friend, may I know what would be the starting slope? Until and unless s to the power of m term has not been present over the system, the starting slope is simply going to be 0. Yes, so what I would do whenever you had this sort of problem, no, how do you start the solution? Always focus over the starting slope. Starting slope is being 0 dB per decay. Why? Because the term of s to the power of m has not been there. S to the power of m has not been there. Agreed? No? So now what we had been doing, we would be talking about the critical point or cutoff point at which the slope would start or slope would change. So the multiplier of s is gonna be the factor of tau, and once you'll take its inverse, you will be getting that critical point. So what I would say, whenever you had the standard form of the transfer function, no, this multiplier factor you had to take an inverse of it, and whatever the value you get, that is being the cutoff point or the critical frequency of that particular operating frequency. Agreed what I'm saying? If we take the reference of this had been 1 radian per second. 1 radian per second, and may you know, after 1 radian per second, what would be the slope now? The slope would change from 0 dB to minus 20 dB per decay. Why it's so? Because now there had been the introduction of one pole, and it had been seen because of the introduction of one pole, the slope would be minus 20 dB, because of 2 minus 40, because of 3 minus 60, because of 1 0 plus 20, because of 2 0 plus 40, so on and so forth. So on and so forth. Did you understand what I'm saying? So what I'm saying, from here onwards, the slope would change its worth from 0 dB per decade to minus 20 dB per decade. Again, what we are going to do over here, we are going to take a BMP plane where the x-axis is being the frequency axis, and similarly y-axis is being the magnitude axis in dBs. Agreed? No? Till this point, nobody should have any doubt as such. So what had been happening over here, let me take operating frequency omega is equals to of 1, and here it had been taken omega is equals to of 0.01 you can take, or 0.1 you can take. Till this point there had not been any movement, no, it had been simply been kept quiet, and after omega is equals to 1, what happens? The slope had been changed from 0 dB per decade to minus 20 dB per decade. What does that mean by the minus 20 dB per decade? That means when the operating frequency omega reaches to 10, no, the magnitude would reach to minus 20 dB. Why so? Because in each decade the magnitude has to reduce by the amount of 20 dB. Yes. Till this point, probably each and everything must be clear to all of us. Now I think it's the right time to focus over the second question, and let's take the second question. Had been like GSHS is equals to 1 divided by of s plus 1 1 plus 10 of s, 1 plus 10 of s. Yes, no, the same thing has been happening. If we'll talk about the initial slope, if you talk about the initial slope is gonna be 0, because the factor of s to the power of m is been absent. May you know first corner frequency which we are going to have over the system? Because of this, the first corner frequency would come at 1 radian per second, and because of this, the first corner frequency is going to come at 1 divided by 10, and that's being 0.1 radian per second. So here, the first corner frequency we are going to have over 0.1 radian per second. 0.1 radian per second. Yes, so we can agree on that. And then what happens? After 0.1 radian per second, there had been the introduction of a pole. So initially slope was 0 dB per decade. Initially the slope was 0 dB per decade. And now would change to, because of one pole, would change to minus 20 dB per decade. Minus 20 dB per decade. Yes, minus 20 dB per decade. And now the next corner frequency we are going to have, because of s plus 1, is that omega is equals to 1 radian per second. And now there had been another introduction of a pole. Already the slope was minus 20 dB per decade. And now because of another pole, and that's been the single pole, minus 20 dB per decade would be further included into the last slope. Last slope was minus 20, and now it would be switched to the minus 40. So the slope had been changed to the minus 40 dB per decade. Now, one of the important conclusion I would like to deduce out of it, if we'll talk about the final slope, may you know what had been the final slope? The final slope is nothing but the slope of the BMP when the omega had been tending towards infinity. What had been the final slope? The final slope had been minus 20. Similarly, what had been the final slope over there? The final slope is been minus 40 dB per decade. One of the important conclusion you can retrieve out of it, it's been the final slope of BMP would always be equals to of plus 20 within the bracket Z minus of P, where the Z had been the open loop zeros over the OLTF, and similarly P had been the open loop poles over the OLTF. Yes, like in this case, if you'll feed the data over here, the number of zeros have been 1, number of poles has been 0. So the final slope is simply going to be minus 20 dB per decade. Similarly, here if we take this reference of this problem, number of zeros had been 0 and number of poles we had 2. So the final slope is simply going to be plus 20 minus of 2, and that had become minus 40 dB per decade. Why it had been happening so? My dear friend, if the number of poles and zeros are being equal, what would happen? Because of zeros, there would be an introduction of plus slope. Because of poles, there would be the introduction of the minus slope, and they would compensate each other. So what I'm saying, if the number of zeros as well as number of poles are being same, no, at least the final slope is simply going to be 0. Now, if there had been the deficiencies or there had been the disbalances, in that case, if the zeros are being more, because of that, the plus 20 had been pumped towards upside, but poles had not been able to suppress it. So what happens now? The slope is going to be positive, so on and so forth. So probably the student who had a little bit idea how the complete BMP is being drawn, no, they can correlate this concept very guess. Agreed? No, again the same thing is being done. We would again take the BMP plane where real axis has been the axis of frequency, and similarly imaginary axis has been the frequency of what? Component of dBs. So let me start with 0.1 radian per second. Let's take it had been 0.01 radian per second. Here it had been 0.1 radian per second. Before than this is the magnitude is being 0, no? And from here onwards, the slope had changed from 0 dB per decade to minus 20 dB per decade. So from here onwards, the slope had changed its value. It had become minus 20 dB per decade. It had become minus 20 dB per decade. Minus 20 dB per decade. Yes. And once we reach to 1, what happens? The slope changes from minus 20 dB per decade to minus 40 dB per decade. Minus 40 dB per decade. Just a minute. And if we'll talk about the final slope, obviously, sir, the final slope had been minus 40 dB per decade. Minus 40 dB per decade. So till this point, I don't find any of the student would have any kind of doubt now. Yes. If you would like to know what would be the magnitude over here, see the rate at which the magnitude was dropping its value is being 20 dB in each decade, and from 0.1 to 1, obviously it had been 1 decade. So how much reduction in the magnitude would take place? It had been sitting over the 0 dB, and now it would be sitting over the minus 20 dB. So I can say here the worth is simply gonna be minus 20 dB. Simply here it's gonna be minus 20 dB. Let me take the reference of omega is equals to of 10. In between 1 to 10, the rate of decrement of the magnitude is being 40 dB. That means in each decade, the magnitude is going to get shrunk by 40. So 1 to 10, what is happening? 1 to 10, what is happening? There had been the jump of 1 decade, so that the magnitude would be reduced by 40 dB from the earlier magnitude. The earlier magnitude had been 20 with a minus sign, would be subtracted with the 40 again. So obviously, here the magnitude which we are going to get, it's going to be minus 60 dB per decade. Yes, perfect, yes. The answer which we are going to get here, it's going to be minus 60 dB per decade. Now I think it's the right time to focus over the next question. Read the problem carefully, then only you must be able to answer it. It's been s plus 10, s plus 10, s plus 1. The question is almost very same as we had earlier. But what you had to do, let's take this as been the third question. Whenever you had a problem in a non-standard form, that means the problem is not been in a form of 1 plus s tau 1, s tau 2, s tau 3 divided by s tau 1, s tau 2, s tau 3. First, you had to convert the given problem into the standard form. Why? I think this is not the right time to discuss about those, but yes, it had got a proper reasoning why we do so. What we would do, the 10 had been taken common. As the 10 had been taken common, the factor which had been left out is been 1 divided by 1 plus s, 1 plus of s divided by 10. And now it had been the standard form. Now it had been the standard form. Hamza, probably you had come into the last story of the control system and you are saying that I am not able to understand. My dear friend, if you have to learn certain story, at least you have to begin not from the very beginning. So at least you have to beginning from the interval onwards. And now if you'll say, sir, movie was almost getting in and I am not able to understand what had been the movie was meant for. So obviously it is a but understood reason you would not be able to understand it. Yes, no? So Hamza, I think one of the easiest subject within your GATE syllabus, PSU, either you take the reference of EAC and that's been the control system. So I won't say it's been a tougher at any case or any cost. So what we had been doing over here, so 1 upon 10 had been a multiplier factor and which would be taken as K, Anyways, we come across this situation, no? So what we do, first we suppress the K. We used to take the K as 1 itself and we would like to draw how it would look like. And once we are done with that, again we would bring the concept of K in a picture and from there the complete BMP would be drawn. So what I would do, at very beginning, let me do one thing. Let me suppress this factor to 1. So how many number of poles you had? 2 number of poles you had. Do you have any initial slope? No, sir, because I do not have the concept of s to the power of m. So the initial slope is simply going to be 0. So rather doing here and there, straight away we can stick to our basic concept or the basic procedure which we had followed so far. The x-axis has been the axis of operating frequency omega and y-axis has been the axis of magnitude in dBs. Yes. So what we do at very beginning, we'll see what would be our initial slope. Sir, I did not have any of the pole or 0 at origin. So obviously, thanks dear Chandan Kumar. Okay, so what I'm saying, the initial slope is simply being 0. Why the initial slope is simply being 0? Because the factor of s to the power of m had not been present over this OLTF. Either it's been s square, s cube, either it's been 1 upon s, 1 upon s square, 1 upon s cube. So as far as this problem is being concerned now, so initial slope is simply going to be 0 dB per decay. And now if you talk about the first corner frequency which we have over the system is being 1 radian per second. So at 1 radian per second, you are going to have the first corner frequency or the change frequency. What does that mean by the corner or the change frequency? The frequency from which the slope of the given BMP changes. Agreed? No? So may I know, because of one pole, how much change in slope takes place? Because of one pole, there would be the introduction of minus 20 dB per decay. So from here onwards, the slope would change its worth from 0 to minus of 20 dB per decay, and that results minus 20 dB per decay. That had been minus 20 dB per decay. May I know till which particular value it would last? It would last till omega is equals to of 10, and from there onwards, it would change to minus 40 dB per decay because another one pole had been introduced. Yes, no? So more or less, if you really wants to draw how the curve would look like, till omega is equals to of 1 radian per second, the slope was 0 dB per decay. Similarly, from 1 radian per second onwards, minus 20 dB per decay, it had been like this, minus 20 dB per decay, and then had changed to minus 40 dB per decay. Yes, no? Even if you want, we can take a reference also. Like this. Omega is equals to of 1, omega is equals to of 10. The slope was minus 20 dB per decay. And here the slope was minus 40 dB per decay. Yes, no? Till this point, there should not be any problem as such. My dear friend, the DS is saying, sir, it should start from minus 20. Yes, But here the k had been taken as 1. K had been taken as 1. And we have already seen what used to be the effect of k. Because of k, there would be the complete shiftment of the BMP with the worth of how much? With the worth of 20 log k. And the k had been 1 upon 10, which had been 0.1. Once you'll take log base 10 of 0.1, that would lead minus of 1. Minus of 1 gets multiplied with 20, and that would be minus 20 dB. So what I'm saying, the complete curve is going to get shifted by the 20 dB upwards or downwards. As the polarity is being negative, it is going to get shifted downwards. It is going to get shifted downwards. So what I would say over here, this complete BMP is going to get shifted like this. It's going to get shifted like this. Like this, yeah. And this has been your actual curve. This has been your actual curve. Just a minute. This has been your actual curve. It had been lowered by 20 dB. It had been lowered by 20 dB. So I would request to each one of you, whenever you had the value of k which had not been 1, you can use this methodology. You can use this methodology. Any chit chat sort of thing, if you want to do with me, you can do it here. You can do it here. But otherwise, probably this would be the last class of my control system. If you really want to learn something new, or the part which you have not learned earlier, what you can do, you can take the reference, of my old video as well. And we are also coming up with the crash course on our main channel, and there obviously our way of communication would be perfectly in Hindi alone. So you guys would not have any doubt, at least. DS, if you had any doubt, my dear, I would just request one thing: Sonal sir control system, use type, and once you'll type, you will get a playlist over the Gate Academy Global itself, and there clearly it had been marked the which video had stands for which particular topic. So I think reference would become much easy. And DS, as you had been following me now, so I would just request one thing: be in contact. So you can at least message me personally also, because you had been following me now. So the student who follows any of the teachers, the teachers has also get a responsibility that the person must do good into his particular curriculum. Sir, give some tips for the gate. How many students? My dear friend, I would say one thing. The tips for the gate, I would say only one thing: stick to the basics. And the different kinds of the subject which you might be reading from any of the coaching institute, either of the videos, either of the live classes, if you're not able to learn the basic concept behind that particular subject, I think that's the right time to start reading a bit from the book itself. Like in my case, I was not that good student in BTech. So when I used to read from the Dande, I was not able to digest all of the concepts. So what I did, end of the day, I thought that most of the students are able to grasp the concept. They are able to do even in weekly test, but I was not able to do the well in my weekly test. So I thought my way of preparation and the way the people had been preparing is going to be something different. So what I did, I started bunking the college classes. And I started putting the complete effort over the textbook. I'm not saying you need to read the complete textbook, but still reading the textbook makes a lot of sense, specifically if you had not been doing good in weekly test or the different test the different institutes used to held. Sweta Kumari, thanks dear, thanks. So what I would say, if you had not been performing extremely well in your BTech examination, so I think it is the right time to start from the scratch. And one thing has been quite sure, I had seen in my time, many of the times you will feel, sir, I had been reading that part from the book that had been taking a tremendous amount of time, and probably the rest of the student are being moving into the fast pace, so they would go much ahead than me. No, that would not take place. What would happen? Did you visualize that or not? See, probably in mathematics you may have 10 different kinds of gray areas. Probably you may not be able to deal with improper form of the definite integral. You might have a little bit doubt over the random variable. My dear friend, once you'll sit and you will actually learn the concept which had been related to the each and individual concepts, what would happen? Do you know that? End of the day, the dot, it starts getting connected. Dot, it starts getting connected. What does that mean by the dot? It starts getting connected. That means the same point now where you were getting stuck in mathematics, probably the same thing would come in signal system. The same thing would come into the communication system. And as you have not learned that concept in mathematics, you are not able to deal the same concept over the signal system as well as communication. And you will feel like, sir, I am not been meant for the gate. Whereas you had been lacking behind only and only one concept, probably that is the random variable. So what I say, when you start sitting and you start smashing each and individual doubts you have, no, end of the day, what happens? Do you know? All of the dots would start getting connected. And if you have learned something new in mathematics, probably you would be able to attach that concept into the different subject. Similarly, once you have learned this concept which you are not aware of, now you will attach this concept with the different subject. And end of the day, what happens? Do you know that? I won't say in electrical, electronics or instrumentation you had 11 or 12 number of subjects. I would say they all had been interlinked. You can't even say the signal system and the control system had been the two different parts. No, you can't say. Your way of understanding the thing had got changed, but there also you had been using the Laplace transformation. There also you had been doing the study in the time domain. Here also you had been doing the study in time domain as well as Laplace domain. Pavitra Lakman, she had one doubt. Pavitra, I would like to have the input from you. The branch, as you had been mentioned over the chat which we had been doing, you had been specifically from which branch? Whether the branch name which had been written over your degree or supposed to get from the degree is been instrumentation, or whether it had been electronics and instrumentation. Electronics and instrumentation. In my case, I had that problem here. Really, I am saying in my case, I had that problem. I used to think all of the students had been moving much faster than me, and I had stuck at a certain point. So I thought my way of preparation and the people used to do the preparation had to be different. I am from instrumentation and control engineering, sir. So Pavitra, I would request one thing: if the electronics is not been mentioned anywhere, no. So what happens once you pursue your MTech from any of the IIT? End of the day, what would happen? The company who is hiring you, know, they may have that problem that the electronics is not been written in your degree. So probably you are not from electronics, although your syllabus must be copied and pasted from the electronics. You must have studied all of the important topics related to the VLSI, electronic devices, analog control. But still what happens? Sometime if the name is not been marked, no, it becomes a big problem. So I would request one thing. You prepare for both. You prepare for both. Sir, it had both core subject of EC. I can understand. I was aware of that. Pavitra, as you are saying, no, that sir, it had the EC as well as EE. But nobody is going to look inside your syllabus. They would just say in which branch you are from. So as you say you are from the instrumentation and control, no, probably they would not be giving the weightage that you had been from the electronics. This year, this had been the trend. For the electrical people, the scorecard had gone much use. That means like if I'll compare with the rank as well as scorecard, in compare with the rank, the scorecard is very good for the electrical people. So many of the electrical people has also entered in the electronics branch. I have seen many of my students, they have entered in optoelectronics, although they are from electrical. Similarly, they have also entered into the RF and microwave technology, although they are from electrical side. So I would not be able to say much here. Pavitra, as the electronics is not been mentioned on your syllabus, no. So probably it becomes a big difficulty in future, although you know each and everything regarding the electronics, but still you may face the problem. So do one thing, you can switch to the electronics. No, Pavitra, you can do one thing. No, you can do one thing. almost many of these subjects, many of the topics would remain concurrent. And if you talk about the job prospects, once you do the MTech from the instrumentation background and the electronics background, definitely in electronics background you had got the huge opportunity in compare with the instrumentation. So I won't say you had to be biased towards instrumentation alone, but managing electronics as well as instrumentation is not possible, because now the machine is also being introduced within the instrumentation. Electromagnetic theory is also being introduced within the instrumentation, and the electromagnetic theory which is there within the instrumentation and the electronics is completely apart. I can say they had been inverted part. The electrostatics, magnetostatics had been the part of instrumentation, whereas in electronics, the complete syllabus starts from the wave theory. So I would say one thing: you won't be able to manage both. That is for sure. You won't be able to manage both. That is for sure. If you really think that I wants to go into the electronics domain, so you can do one thing: you can choose the electronics, but somewhere I am saying you may have the problem, because few of the branches you cannot opt in MTech, because they had been meant for the electronics and communication alone. Even the electronics and electrical people cannot opt those branch. So prospects wise, obviously electronics is good in compare with the instrumentation. Few of the important branches like VLSI and all, you can go there, no issue. VLSI you can use. Microcontroller as well as image processing, you can go ahead, no issue. So this many important branches you can opt being a instrumentation engineer if you had been sitting in the electronics. But probably the communication part, communication engineering for the MTech, you cannot opt. But communication is not been that demanding. What I'm saying, the communication is not been that demanding. So now it's your call. Now it's your call. Which one you would like to choose? Which one you would like to choose? Okay, I want to do the job, sir. So I would say go ahead with the instrumentation. Go ahead with the instrumentation. You need not to rethink at all. Just go ahead with the instrumentation. Because in instrumentation, if you'll say the proportionality constant, that's a very important constant. Proportionality constant. How many number of students are being sitting and how many job vacancies are being coming out. The X has been the number of students who had been appearing in GATE examination, and similarly with the reference of GATE examination, how many number of seats are being coming out. So if we'll say Y by X ratio, no, Y by X ratio in instrumentation is much greater than the Y by X ratio in electronics. What I'm saying, in electronics, that I can ensure you. Even in NTPC, they require more instrumentation people than the electronics people. Similarly, in all of the oil sector, either you take ONGC, GAIL, BHEL, not BHEL, it's not oil sector. There also Y by X ratio for the instrumentation is larger than the Y by X ratio of the electronics. So if you want to go for the government job, no. So I think stick to this. Stick to this. Okay, Pavitra. So probably I could give the expert suggestion which you wanted to know from me. If you have any doubt, you can ask. Sweta Kumari, thank you, dear. Is your health okay? I don't find that my health is okay, but still, I don't want to bunk my class. That's why I have taken today's class. Thanks, dear. Thanks, Sweta, to ask this. If you guys are having any kind of doubt, you can put it over here. Otherwise, we would stop our session as well as the complete control system here itself. Okay then. Okay, sir. Thank you very much. Thank you for dedicated your time. No, dear. If you had been following us and you had given your complete trust on us, so definitely it's our responsibility to at least calibrate your actual performance to the outcome. There is no doubt as such. Okay, this is all about the today's class. From tomorrow onwards, we won't have the class for the control system, because almost part of the control system is been over. Only and only one part is been left out. That's been the state space. So you just type state space Sonal, sir. Again, you will be getting the videos, probably 2 or 3 hours span of video from this topic, and the complete control system would get over. So we had the very good journey over the control system. So I would expect if you guys are having any kind of doubt, you can put it over the Telegram group. We can have the separate session for that also. Is that part clear? Till then, bye bye. Take care. Good night.